Okay, last section this entire semester. What that means for you is that after this section, you start reviewing for the test for Chapter 7. Then you will take the test for Chapter 7. Then you will review for the midterm, which is everything we've done so far. And then you will take the midterm test. So you still have 2 tests to take, 2 reviews to do, some time. It's not all over with yet. But this is the last video you have to watch before you're done for Christmas. Yay! So after this video, you don't have any more videos to watch. All you gotta do is some reviewing and some testing, and hopefully you will get all that done in a nice, timely fashion, and you can have a break over Christmas. I do not want you to start back, I hope this works out, until around the middle of January. I think your mom will be okay with that, because that gives me some time to build up a little bit to stay kind of ahead of you. So that way I get a little bit of a break over Christmas too, instead of having to work the whole time on you. I can just work part of the time. So there's my little hoping that can happen. And I don't think your mom will have too much trouble with it, because I think she'll want to make sure you are back into the swing of things before she starts adding this in on you. So this is section 7.7. Hopefully it'll go kind of fast. This is when they take all the information that they've given you thus far and add all the interesting math geometric stuff to it, and then you are left on your own to be able to do some problems. And when I say left on your own, I mean for real. I'm gonna leave you on your own. We're gonna see what you can do. So most of this stuff I have already talked about ad infinitum, because I thought they had already told you about it. So see, now look at that. Now you're ahead of the game. Isn't that great? So going back to this, if you have parallel sides and they share an opposite angle, then a common angle, which means you got 2 triangles within themselves, then they have to be similar triangles. And that means that there are some great things about this similarity, which means that, you know, you have the whole A over F, because that's the little triangle, and then the big triangle, and that would have to be equal to B over E. That one you've known about. We've done that. Same thing with C over F has to be equal to D over E. We've done that one too. Same thing with A over C has to be equal to B over D. That one we haven't done. I've been very careful not to do that one, but now I can throw it in there. And I don't know if you've noticed, but I always do the same side in the same, you know, fraction. So that kind of helps you out as to knowing which one to pick, and don't just throw letters up there willy-nilly. We've talked about that in the past too. Even if there isn't a common angle, you can do that, which is what this whole section is about, which means that I can say same line in the same fraction. So A over B is going to be C over D. Or I could say same segments in between the same parallel lines are in the same fraction. So A over C has to be equal to B over D. Yeah, because you get the same cross product either way. AD and AD, BC and BC. So you're probably going to be pretty covered on that. And then this one is a kind of cool one. It says that if you buy, now they have altitude ones in there. They have some other ones that you've highlighted that you're going to have to write down. I'm not telling you not to write them down. What I am telling you is this one is kind of cool in that when you start getting a bisector in there of an angle, and you can tell it must be a really cool one because I gave it a cool name too. So it gets its own special name. It's just not got a number to it. But when you have a bisector of an angle like this one here that bisected that whole angle, then that means that this little part is proportional to that side of the triangle, and this other part is proportional to that side of the triangle. So we end up with A over D is equal to B over E, or you can do it the other way, which I think is what your book leans towards, doing the side that gets split up, because normally it's A, B, and C. The side that gets split up goes on top, and they do D over A is equal to E over B. So those are the facts, which leads us to the classwork. I know what you're saying. Wait a minute, you ain't showed me nothing new. Ain't done no problems yet. That's true. I want you to go ahead and try the classwork on your own because we've been doing some stuff. I want you to see how far you can get on it. When you're done trying the classwork, then you come back to the video. I'll go over the classwork with you. Isn't that grand? And then you can go ahead and do your homework. And you'll be done. I'm just saying. Trying to make things simple. So the classwork for today is on page 295 and I think 296 because you have to turn the page to get to number 20. But it's problems 1, 7, and 20. So go ahead, pause, take some time, see what you can do on 1, 7, and 20. And then after that, come back, press play, and I'll go ahead and show you how to do them. No, really, I will go ahead and show you how to do them. Okay, fine. I'll go ahead and show you how to do them right now. Gosh, so picky and busy. Some people. Okay, so first thing I'm going to do is plug some stuff in. So they said AX is 6, so I'm going to write the 6. They say BX is 10, so I'm going to write the 10. They tell me AY is 21, I'm going to write the 21. I know this doesn't look like it does in the book, but it's good enough. So all I have to do is set up my proportions to figure out what YC is. And AB, I can already tell you is 6 plus 10 is that's 16. That's good. So I'm going to say 6 over 21 has to equal 10 over X, which gives me 6X is equal to 210, which divided by 6 is a big number. X is equal to 6 goes into 21 3 times. With 3 left over, 6 goes into 35 times. So I get this is 35. Which means 16 over 56 must reduce down as well. 2 over 7. That is 56, right? That is 7, 2 over 7. Oh, that is 2 over 7. Huh. And 10 over 35 is 2 over 7. So I'm good. Just making sure I'm right. Do a little bit of checking myself. Okay. So those are the answers that I get. Going on to the next one. Once again, I'm going to fill in some stuff. DE, they told me was 3. DF, they told me was 5. EF is 16. I need to know what this is. And if that's X, that means this one is 16 minus X. Just saying, throw a little bit of algebra in there and it comes out just fine. That means that 3 over X has to equal 5 over 16 minus X. That gives me 3 times 16 is 48 minus 3X is equal to 5X. Move that over here. 48 is equal to 8X. So X must be equal to 6. So EP is my 6, which means PF must be 10. 3 over 6 equals 5 over 10. Look at that. That's pretty, Aunt. That's good stuff. Now, in order for me to do this one, I'm going to need some space, so I'm going to erase something. So that I can write it where you can see it. Okay, I'm going to erase a lot. You'll be all right. Could erase that too, but I'm not. I'm leaving it for you just so you can write stuff down. Okay, so for this one, they want to know for what value of x is this really going to be parallel to that. Well, we've already learned that things would be workable, but I don't want to get squares in there. So if I had set it up as x over x plus 7, is that really a 7? Yep, it's really a 7. Equals x minus 3 over x plus 1. I'd start doing some cross multiplying, getting some squares in there, and that just doesn't appeal to me. Not saying you can't do it that way, just saying I'd rather not do it without squares, personally, just me. So that being the case, instead I'm going to try small triangle over big triangle. So my small triangle is x. My big one here is going to be x plus 7. So that's going to be 2x plus 7. Has to equal, over here I've got x minus 3 on top, over big triangle is going to be 2x minus 2. I still got squares. Oh well. Do them both. We'll see what happens. So here I get 2x squared minus 2x equals 2x squared minus 6x. See, it's all the foiling. 2x squared minus 6x plus 7x minus 21. So now I have 2x squared minus 2x is equal to 2x squared plus x minus 21. Okay? When I subtract 2x squared from both sides, that cancels them out. I'm left with negative 2x is equal to x minus 21. Moving my x over here, I get negative 3x is equal to negative 21. X is equal to 7. Just to see if I get the same thing up here for x, I'm going to try it. So up here, I would get x squared plus x is equal to x squared minus 3x plus 7x minus 1. So x squared plus x is equal to x squared plus 4x minus 21. Then my x squares cancel each other out because I subtract x squared from both sides, they go away. I'm left with x is equal to 4x minus 21 with my 4x over negative 3x equal to negative 21. Look at that. X is still equal to 7. Now, this is the only caution I'm going to give you. When you have a problem like this and you get x is equal to 7, that's great, fine, and wonderful. X can be 7 in all of these places. But if you end up with x being a negative number, you need to stop and start thinking about some stuff because x can't be a negative number. X has to be some positive distance. So if you end up with a negative number, that means you probably made a mistake somewhere. So understand that. The whole foiling thing, I didn't want to catch it too far off guard. So there's that, which leads us to the homework, because you've already done the classwork. See, aren't you excited about that? Now on to the homework. Page 295. Whole bunch of problems. Numbers 2, 6, and 8. That's an 8. That's it. That's it for chapter 7. All you got now is a review and a test. Your mom should have those. Much love. See you later in January. Okay, bye.